this question is the coolest question ever. If we ever get a chance, if it's sunny enough and it does stops raining for like a couple consecutive days, we might be actually able to go outside and do this one. But it says the height of an object compared to the length of its shadow is constant for all objects at any given time. Use this information and a drawing to help answer the following questions. Let's look at the first one. It says, if a 20-meter tower, so here's my tower, just like this, with a little gate here, and it's got, I don't know, a little maiden in here with hair, Rapunzel maybe. She's in the help me. So if a 20-meter tower, this is 20 meters tall, casts a 12-meter shadow. That doesn't look like a shower for the tower, but we'll just pretend. That shadow to object proportion is proportionate to the tree that is casting a 3-meter shadow. So let's set that up as words first. So the object to shadow ratio will be proportionate always. So 20 meters with the tower to 12-meter shadow will be proportionate to the object height or the tree's height compared to its shadow. What did I do to 12 to get 3? Well, I divided it by 4. So therefore, if I keep it proportionate, I would divide that. And that would tell me that this tree here is 5 meters tall. Pretty nifty, isn't it? Hopefully I didn't go through that too quick. I did do it quick, but we'll erase this and look at the second one. The second one's kind of neat too. All right, the second one says if a 25-meter building, there's our building, it's 25 meters tall, has a shadow of 8 meters long, how big of a shadow will a 1.6 meter student, there's the 1.6 meter student, I realize it's disproportionate, but that's okay. How long will the shadow be? So again, we're going to have this object to shadow ratio. And we'll say the object for the first one that we know is 25 meters, and its shadow is 8 meters. That is a ratio. That will be proportionate to or equivalent to whatever you want to use. The object, which is the student's height, 1.6 meters, to its shadow. Now, let's look at how am I going to figure out what this is. Well, what did I do to 25 to get 1.6? If I wanted to know what I divided by, what do I divide 25 by? Let's make an easier question. If it was 10 and 2, right, if these were the numbers, what did I divide 10 by to get 2? Well, I knew I divided it by 5. So this number divided by this number will tell me what this number is. Is that right? I guess that's right. So let's do 25. 25 divided by 1.6. That equals 15.625. Is that right? That can't be. I did that wrong, did I? 25 divided by 1. Oh, I didn't have my decimal there, I bet you. No, I did. Is 15. That's right. It's 15.625. That's right. So 15.625. So if I divide by 15.625, let's just double check that. 25 divided by 15.625 equals, I get 1.6. So if I divide this one here by 15.625, what is 8 divided by 15.625? And the answer is 0.512. 0.512 meters. Well, that doesn't really help. That's just a little bit more than a meter, but how much is that? Because we really want that to the nearest centimeter. So 512, 0.512 meters is actually 51.2 centimeters, because there's 100 centimeters in a meter. So half a meter would be 50 centimeters, and 0.512 meters is 51.2 centimeters. Congratulations, you finished the review.